So in this question, we've been asked to find the eigenvalues and the eigenvectors of our matrix B. Now, to find the eigenvalues of any matrix, we're going to use the characteristic equation, and the characteristic equation is giving us the determinant of B minus lambda I equal to 0. And for us to get the eigenvalues, we're simply going to use the formula B minus lambda I multiplied by V equal to 0, where V is our eigenvectors and the lambda is our eigenvalues. So for each eigenvalue, we are going to have a corresponding eigenvector. So these are the two formulas that you need to know. And what we need to do is simply to apply these two formulas. So the first thing we need to do is to get the eigenvalues, and we're going to use the first formula to get the eigenvalues. So the first thing you need to know is I is our identity matrix, B is our matrix. It can be anything, it can be M, it can be A, right? It's not standard. This is not like the standard formula, but the variables changes. So in this case, our I is our identity matrix, which is 1 0 0 0 1 0 0 0 1. Therefore, our lambda I will simply be lambda 0 0 0 lambda 0 0 0 lambda. And we are taking B minus lambda I, we're simply going to subtract corresponding component, meaning that 1 is going to be subtracted from lambda. So we're going to have 1 minus lambda as our first element and 0 0, and then we're going to have 0 here, 1 minus lambda, right? Okay, so our B, right? So our B in this case, okay, now this is our lambda I, right? So our B in this case is 2 0 1 1 1 1 and 1 0 2. Great. So now to get the value of B minus lambda I, we're simply going to subtract corresponding components. So meaning we're going to have 2 minus lambda as our first component, our first element, 0 0. Then we're going to have 0. So we're going to have, so 2 minus lambda is going to give us 2 minus lambda 0. So now in order to compute B minus lambda I, we're simply going to subtract corresponding components, meaning that we consider this, right? We subtract with this, we consider this, we subtract with this, we consider the third element, we subtract with that, and we do the same thing for the other elements. So we're going to have simply 2 minus lambda as our first element. 0 minus 0 is giving us 0. 1 minus 0 is giving us 1. So we do the same for the second row. So it's going to be 1 minus 0 is 1. 1 minus lambda, we have 1 minus lambda, and 1 minus 0 is 1. So the next is 1 minus 0 is 1. 0 minus 0 is 0. 2 minus lambda is 2 minus lambda. So this is our matrix B minus lambda I. So we have to look for the determinant of B minus lambda I, and we equate that to 0 and solve for the value of lambda. So doing that, we're going to look for the determinant of this. We already saw earlier that the determinant is simply considering the parity matrix, right? Considering a parity matrix and a pivot. In this case, we're going to consider this as our pivot, right? This is going to be our pivot. There is also a 0 here, so it's going to simplify work. So we're going to consider 2 minus lambda here, and our sub matrix is simply 1 minus lambda 1 0 2 minus lambda. So we're done with that element. Now if we consider 0, right, everything is just going to give us 0, so there's no need writing that. And even considering the parity is like minus 0, which is still going to be 0. So plus our next parity is positive, right? So it's positive, the value is 1, and our sub matrix is 1 1 minus lambda 1 0. So that's it. This is our main focus now. We have to look for we have to equate that to 0, simplify and equate to 0, then solve for the value of lambda. So it's very easy to do that. So it's 2 minus lambda, then the determinant here is 1 minus lambda. So I will change this bracket here to be something like this, 2 minus lambda, so minus 1, so plus 1 into, so this will be 0, minus 1 minus lambda. So we are going to have that, and if we expand this, we're going to have 2 minus lambda into, this will be 2 minus lambda minus 2 lambda plus lambda squared minus 1, then plus 1 minus lambda, plus 1 minus lambda. So we're going to have 2 minus lambda into 2, so if we simplify this, we're going to have lambda squared minus 3 lambda plus 1 plus 1 minus lambda. So we're going to further expand this. Yes, we're going to further expand this. So we're going to have lambda squared minus 2 lambda squared minus 6 lambda plus 2, then minus lambda cube minus plus 3 lambda squared minus lambda, then plus 1 minus lambda. Remember that this was all equal to 0. So what happens here is we are going to have our lambda cube, right? We're going to have our minus lambda cube, so we're done with this, and squared will be plus 5 lambda squared, so we're done with this. Then we have minus 6 lambda minus lambda, so it's minus 8 lambda, so we're done with this, and plus 3 equal to 0. So if we multiply all through by negative, we're going to have lambda cube minus 5 lambda squared plus 8 lambda minus 3 equal to 0. So obviously this is a cubic equation, meaning that there are 3 solutions. So there is lambda 1, lambda 2, lambda 3. Now, in order not to waste a lot of time and make the video to be very long, I will simply state the values of lambda which I've already solved, and the different values of lambda is lambda 1, lambda is equal to, lambda 1 is equal to 3, lambda 2 is equal to 1, and lambda 3 is equal to 1. Now, there are many ways in which you can solve this. I'll just give you a hint on how to solve this. So the first thing is here you can consider the try and error method. Now the idea with the try and error is you consider the value of lambda to be 1. Assume the value of lambda to be 1. You insert it here. If it gives you 0, then lambda equals to 1 is a root, and lambda minus 1 is a factor. If you know that lambda minus 1 is a factor, you go through the long division, right? And you're going to simplify this cube to square, and with the square you use either the factorization method or the formula method to get the values. So ideally, if you try lambda equals to -1 and it gives you 0, which is actually the case, then you're going to have lambda, then lambda equals to -1 is a factor, and lambda plus 1 is a root. And again, you go through the long division method. So if you try this and it didn't work, you try a different value. If it doesn't work, you try another value like 2. If it doesn't work, you try another value, and so on. Once you do that, at the end you just conclude, and you use your factorization method to simplify everything. But as I mentioned, I've already solved the details of this, and here are the different values of lambda. There's no need to waste time solving it here. So lambda 1 is 3, lambda 2 is 1, and lambda 3 is 1, which makes our life much easier. Now, these are the eigenvalues of our matrix B. We have to get the eigenvectors. So as we saw, to get the eigenvectors, we are simply going to have, to get the eigenvectors, the formula, let me change the color, is B minus lambda I V. So meaning that equal to 0. So meaning that we're going to have B minus lambda 1I, right, V1, to better represent it. So lambda 2 v2 lambda 3 v3, and note that v is a column vector, or column vector. So that's what we're going to do here. We already saw somewhere above that our b minus lambda I, alright, we already saw from here that our b minus lambda I is this value here. This is our b minus lambda I. This is our b minus lambda I. So I'll copy this. So this is our b minus lambda I. So the first thing we need to do is we say when lambda is equal to 3, the first thing we need to do is substitute it here. So we're going to have 2 minus 3 here, 2 minus 3 here, which will give us minus 1. So minus 1, 0, 1. Here we're going to have 1. So 1 minus 3, right? So this will be 1 plus 3, which is 4. And then 1. Then 1, 0. 2 minus 3. You get the point. So first of all, here is actually 1 minus 3, which is negative 2. So note that 1 minus 3, because our lambda is 3, not minus 3. Okay, so 2 minus 3 will simply be negative 1. So this is when lambda is 3. When lambda is 3, this is our value. Remember, I have to multiply it with our eigenvector. So we're going to call eigenvector v1, v2, and v3. Then we're going to equate this to 0. So we just solve this like normally, right? So we'll use a swim and dive method to multiply this. So it's this minus this, so it's minus v1. Basically it's minus v1 plus 0 plus v3 equal to 0. We're done with this. We go here, so it should be v1 minus 2 v2 plus v3 equal to 0. We're done with this. Then the third one, v1 plus 0 minus v3 equal to 0. So these are 3 simultaneous equations. We have to solve them for the value of v1, v2, v3. So from these 3 simultaneous equations, what we need to do is express all of them, right? This is what I mean. We have to express all of these equations in terms of one variable so that we can factor it out. So it's all left to you. You can decide to express all of them in terms of v1, or all of them in terms of v2, or all of them in terms of v3. But in this case, we're going to express all of them in terms of v1. If we're expressing all of them in terms of v1, meaning that our v1 is simply going to be constant. Now our v2 from our equation 2 shows that, from this equation 2, it shows that our v2, right, our v2, which is 2v2, is v3 plus v1. We already saw from equation 1 that v1 is equal to v2, so our 2v2 is 2v1, right? So meaning that our v2 is v1. So we are going to also replace this. Our v2 is v1. We'll do the same thing for our third equation. So we have to express our third equation in terms of v1. So v1 is equal, our v3 is v1, v3 is v1. So substitute here, our v3 is v1. So we notice that all of them, right, are all v1, v1. So if we factor out v1, we're going to be left with 1, 1, 1. So this is our eigenvector. So that's our eigenvector. We're going to do the same thing for lambda equal to 1, and I'm not going to compute that. It's going to be an exercise because the videos are already very long. And when you substitute lambda equals to 1, you're going to have the value 1. You're going to have the matrix 1, 0, 1, 1, 0, 1, 1, 0, 1. Right, very interesting matrix. So you multiply it with our x, our v1, v2, v3, and you equate that to 0. Once you equate it to 0, you simply do the multiplication. I can already see that is v1 plus v3 equal to 0, v1 plus v3 equal to 0, v1 plus v3 equal to 0. We already see that one of them is 0 here, and these are three equations, and we can start expressing all of them in terms of the other. So we are assuming to express all of them in terms of v1. We see that v1 is v3, right? So our v1 is v1, that's first thing. Our v2 here, v2 is 0, v2 here is simply 0, and our v3 is simply v1, right? So we're going to have something like v1 is 0, v1, and if we factor out v1, we're going to be left with 1, 0, 1. At the end of the day, I solved the equation. Anyways, so this is our second eigenvector, and that's all that was expected of you from this question, and I hope this was helpful. So see you in the next video.